Hello everybody, welcome to Psych Academy. This is Orko sir, and today we will be having a full class on hypothesis testing from Unit 2 Research Aptitude UGC NET Paper 1. Now, hypothesis testing is an area where students encounter problems frequently, especially in the conceptual areas. So we decided to have a full class on it to simplify the concept and ensure that you have no more problems after this video. It technically comes under the steps of research, that is, after data collection and statistical analysis, you compare it with the hypothesis to see if your initial prediction matches the actual data that you have found. Let's get into it. What exactly is a hypothesis? It is a testable statement. Now, what does this mean? A testable statement, it can be any prediction that you are making. For example, depression can lead to problems in your sleep schedule, or stress can reduce your immunity, or that motivation can improve your performance. All of these are examples of hypothesis. Even a simple thing like it looks cloudy outside and hence there is a possibility of rain, or it might be raining. These are all examples of hypothesis where a prediction is being made, and later, after the data has been collected, then you verify if the prediction was right or not. Now, within this part, we also have the testable area. That what does testable mean? For example, a hypothesis like that God exists, which is why the world is designed the way it is. Now, that is not really a testable hypothesis. You don't really have any means of testing whether or not that is true. Or a hypothesis that in an alternate universe, an exact variation of you is there. Again, this is not a testable hypothesis. So, what I'm trying to mean is that it has to be something that can be verified through scientific experiments. That is what a hypothesis is. It makes a prediction based on available data, whatever data you have already with you. For example, when you are stating that there may be rain because you can see a cloudy sky, you already have a basic understanding that whenever there is a cloudy sky, it usually does rain. You have some data available to you. The sample is selected, then data is collected, it is statistically analyzed to check if it matches the hypothesis or not. This process of verification is called hypothesis testing. Hypothesis testing is the process through which we verify if the hypothesis matches. Hypothesis happens before the sample is selected, but the verification part that happens after statistical analysis. So we will do this entire segment, that is hypothesis testing, significance levels, confidence level, what does alpha level mean, what does beta level mean, what are the kinds of error that can be happening in hypothesis testing through a very simple example. You are about to go out to work. Your mother says to you, it is cloudy outside, it will be raining, take an umbrella. You can say one of these two things, it will not rain, I do not need an umbrella, or yes, it will rain, I will take the umbrella. So in one situation, you are rejecting the statement that your mother has made. On the other situation, you are accepting the statement that she has made. Our formula for this class is that we will take this very relatable example, try to understand it logically the way we are going, because statistics, hypothesis testing, we are going on using it in our daily lives all the time. So we will take the real life example, go into it in the real life route, and then use technical terms to translate it into the way the questions and textbooks refer to. So let's get to it. Your mother's statement can be broken down into three parts. What evidence does she have? It is cloudy outside. This is the evidence on which she has made a hypothesis or prediction. What is the prediction? It will be raining. Now, the point is evidence and hypothesis. The difference is that evidence is something that you already have verified in front of you. Your mother has looked outside the window and literally seen with her own eyes that it is cloudy. Evidence is everything that has already been verified, already established. Prediction is about the future. You do not know if it will be true or not. And this is why first we have to focus on correct evidence. Only then we can focus on a good hypothesis. Finally, a recommendation, that is take an umbrella. If the hypothesis is true, what exactly you should be doing. So for now, initially we will focus on the evidence and prediction part. Let's get to it. Your statements can be reframed in the following ways. It will not rain. This is the common way that we speak. Is equivalent to these clouds are not able to predict rain, which is equivalent to there is no relationship between the cloudy weather and rain. Out here, cloudy weather is the independent variable and rain is the dependent variable. You are trying to think of a cause effect relationship that if there is cloudy weather, there will be rain. So this is the independent variable, this is the dependent variable, the cause, the effect, this is the data, this is the prediction, right? And you are asserting that there is no relationship between them, which is why you state that it will not rain. So whenever we talk about assert that there is no relationship, it is called a null hypothesis. Null means zero. It is written as or denoted as H naught. This zero means that there is no relationship. What's the other side? Yes, it will rain. Is equivalent to these clouds are able to predict the rain, which is equivalent to there is a relationship between the cloudy weather, which is the IV, and the rain, which is the DV. This is the alternative hypothesis. Now, in tests, what we do is we try to focus on the null hypothesis. We try to prove the null hypothesis and see if it can be rejected or accepted. Why exactly do we focus on the null hypothesis more than the alternate hypothesis? That comes under paradigms of research. Paradigms of research tries to discusses what are the research methods that we choose. Right now, we should focus on the method directly. So this one, alternative hypothesis, states that there is a relationship between the variables. So this is the definition of null hypothesis, definition of alternative hypothesis. Study tries to prove the null hypothesis. If null hypothesis is accepted, that is, you accept that there will be no rain, alternate hypothesis is rejected. If null hypothesis is rejected, alternative hypothesis is accepted, because they are just two sides of each other. If one gets rejected, the other one automatically gets accepted. Now imagine, now we have already discussed the kinds of hypothesis that there is. Now let's imagine the actual outcome of rain based on the clouds. These are the four possible kinds of data that we have taken here. It may rain a few drops for 5 minutes. It may rain a few drops for the entire time. It may rain heavily for 10 minutes and not again that day. It may rain heavily that entire day. You have to conclude it rained versus it did not rain. Now for option 1, almost everybody will agree, or there's a consensus that rain a few drops for just 5 minutes, this cannot be considered that to be rain. That we will just accept that it did not rain. So it did not rain is matching with option 1. At the same time, rain heavily that entirely day, this is very clearly rain. There is no other way of looking at it. This is rain. So we are looking at option 4 as it rained. Now this one we have a relation, this one we have a relation. Option 2 and 3, this gets a bit difficult. That is rain a few drops for the entire time. Do we call it rain? Rain heavily for 10 minutes, but not again the entire day. Do we state that the day was raining? Did it rain? So it gets a bit difficult to categorize them. So when we have certain things that, option 2 or option 3, how much do we consider them to have rained or not rained? What we really require is a minimum amount criteria. How much does it have to rain for us to consider that it rained or it didn't rain? That is option 1, very clearly in the it did not rain area. Option 4, very clearly in the it did rain area. But option 2 and 3, to be able to make conclusions about that, we need to have a minimum amount set in our head. That is, what is the minimum amount of rain for it to be called raining? So In option 1, we have the null hypothesis accepted. That is, in option 1, we say that it did not rain. So, which means no relationship, null hypothesis is accepted. Alternate hypothesis rejected. Option 4, null hypothesis rejected because it did rain. There was a relationship between the clouds and the rain. Alternate hypothesis accepted. These conclusions require us to have an implicit measure that we usually are using in our daily lives. What is the minimum quantity of rain for us to conclude that it rained? So for us to conclude means to make a solid conclusion, we need a significance level. What is the level at which the rain becomes significant? That point is called a significance level. We usually have implicit measures of it, which we are not always very aware of. But in statistical tests, in research methodology, this minimum quantity is made explicit through the alpha level or significance level. Hypothesis test is done on the basis of a predetermined significance level. That significance level is simply the minimum amount required for us to say an effect or a relationship is there. That is what a significance level means. The minimum amount for us to conclude there has been an effect. Now, the significance level can be strict or can be lenient. So let's look at this. Now let's look at options 2 and 3. 2 is rain a few drops for the entire time. 3 is rain heavily for 10 minutes and not again that day. If the alpha level, that is lenient, that is, we have a low minimum amount, that even if it just rained a bit, we will consider that yes, it rained, which means we will consider that there is a relationship between the independent variable and the dependent variable, even if for little changes, right? So for a lenient alpha level, a low minimum amount, options 2 and 3 will also be labeled as it rained. So if you make the alpha level very lenient, minimum amount becomes low, it gets very easy to say that there is a relationship. In other words, null hypothesis will be rejected easily, indicating the result. There is a relationship between the cloudy weather and rain. But we will not be very confident about asserting the findings. This part is important. Because if you just look at any tiny bit of rain or any small amount of rain and keep on saying that it rained, then the next time you see the clouds in the sky, your answer will not be taken with a lot of confidence, because you are somebody asking you that do you think there will be rain, and you say yes, there will be rain, and then another person says, this guy, he always says that there is rain, even if it is just 2 or 3 drops. Hence, we should not be taking his word with a lot of confidence. Why do we say that? Because you have made the alpha level too lenient. You are accepting there is a relationship at too little of a criteria. Hence, whenever you are saying that yes, it will be raining or it rained, others are saying, this person just says that it rained even if there was a few drops of water for 10 minutes, right? So in that case, if we make the alpha level very lenient and the minimum amount becomes very low, confidence in the findings becomes very low, which is not something that we want. So let's look at the other option. Now let's look at options. That is, if we make a strict alpha level, again, alpha level is strict, then a high minimum amount is required, and options 2 and 3 will also be labeled as it did not rain. It did not rain means null hypothesis will be accepted. Only option 4 will be able to reject the null hypothesis. That is, only when it rained a lot, then you say that yes, it rained. So in that case, now think of one person who says that it has rained only when it has rained a lot. Now, whenever they say that there is a relationship between the cloudy weather and rain, you are like, if this person is saying that it rained, who does not say it rained even for small amounts, it means that yes, it did rain, which means you are being confident in this person's statement that there is a relationship. So we want high confidence. So for a strict alpha level, confidence is very high. because you are not accepting that there is a relationship until and unless a very strong criteria has been made. A lot of effect has been found, quite a significant change has been found for the IV and DV before you have accepted that yes, these results are significant. So confidence becomes very high. Strict alpha level means difficult to reject the null hypothesis is equal to high confidence in findings. Linear alpha level is easy to reject null hypothesis, so low confidence in findings even when null hypothesis is rejected. And null hypothesis rejected means there is a relationship. Confidence should be high. This is what all research aims for. Hence, alpha level is usually kept strict. Hence, for a very strict alpha level, that is most research, accepting null hypothesis does not prove that there is no relationship. Because we have intention, this is the important part, understand. We have made the criteria for rejection of null hypothesis or criteria for stating that there is a relationship very strict, very difficult. So just because something has not met that very strict criteria does not mean that we can just confidently say that, oh, okay, there is no relationship. No, there can be. It just did not meet that high level of criteria. So accepting null hypothesis does not prove that there is no relationship, but rejecting the null hypothesis means that there is an extremely low chance of probability of there being no relationship. That it would be a very rare coincidence that there is no relationship, because after all the results were so significant. In other words, there is an extremely high chance of probability of there being a relationship. And understand, in science, it is always considered to be a high probability versus low probability, because there are always chances of some data going wrong somewhere, new findings appending other earlier theories, and hence nothing is stated to be absolutely true. It is just that you can say that it is true with a very high level of confidence. Common levels of significance or alpha level are 0.1, 0.05, and 0.01. These are very common, comes in the question, so please remember the meanings of it. Alpha level 0.1, 0.1 is the same as 10 by 100 or 10% chance of error, because alpha level is the chance of error. So let's look at this. This is the alpha level, okay? And whenever we are looking at the data as per our understanding of normal distribution, this is the area where most of the data lies, right? This is the area where, I'll just write it here. This is the area where most of the data lies, in this area. Add a bit here also in this area, which means that this portion represents the usual criteria, usual characteristics. Whenever our data is lying towards the ends of the tails, it means the data is very different from what is normally expected. This is the normal expectation. So then this line is where the alpha level is. This line is where we are drawing our minimum amount. That if this much of rain has happened, then we will say that it has rained. Now what happens is, if you take this line and push it further, instead of here, you make it here, then you see the area becomes even smaller. You push it here, the area becomes even smaller. So the stricter is the alpha level. So basically, the smaller the area, the more difficult is the score to get here, because it is very rare of an occurrence. So the smaller this area, the smaller the alpha level, the stricter is the test, and the more difficult it is to reject the null hypothesis. So the smaller you keep the alpha level, the more confident you can be of your test findings. That if it is rejected, that if the data falls out here, it is more confident than if it falls here, more confident than if it falls here. And each of these are basically stricter and stricter levels of significance. And if the data falls somewhere around here, wherever, just before the alpha line, we will accept the null hypothesis, state that there is no relationship because the minimum criteria has not been met. So alpha level 0.1 is 10% chance of error or 90% confidence. And why 10% chance of error? that if the data falls around here in this area, I'll just clean it up a bit. That is, if the data falls here in this area, based on this alpha level, we are asserting that it is extremely unlikely that it will happen just by coincidence or randomly. It implies that it has an actual effect. So this extremely unlikely that the chance of it falling here is 10% for alpha level 0.1. Hence, 10% chance of it being a coincidence or a random miracle, and 90% chance that it happened due to an actual effect. That is 90% confidence. For 0.05, even smaller, 5% chance of error, 95% confidence. For 0.01, even smaller, 1 by 100 or 1% chance of error, 99% confidence. Smaller the alpha level, this would be, if this is 0.1, this would be 0.05, this would be 0.01. Smaller the alpha level, the more is the confidence. These are the kinds of tests you have based on the kinds of hypothesis. Your alternative hypothesis can be directional or non-directional. Directional means that it creates a direction. For example, stress reduces your immunity, which means if stress is high, immunity will be on the lower side. Or we say that motivation increases performance. So if motivation is high, performance will be on the higher side. So these are called directional. You are stating, will it increase or will it decrease? You are stating the direction. Non-directional means you simply say that stress has an effect on your sleep schedule. You did not discuss about, or even better, depression has an effect on your sleep schedule. You did not discuss if it increases the sleep schedule or makes it better or if it makes it worse. It can go either ways. So when we have a directional hypothesis, so let's look at this one, this graph, that this one that we are looking for. Motivation increases performance. We simply have to look at the increase side, the higher side. And hence alpha level only takes care of this side, one side. If we say that stress reduces immunity. So we simply have, when we are measuring for immunity, we simply have to look at the lower side because it is the reduction part that we are looking for. We are not looking for whether or not stress increases immunity, just the reduction part. Hence, on one side, these are called one-tail test. So this tail that you have, so whenever you draw a normal distribution, these one, these are called tails. This is a two-tail test where you can simply be using both, that is stress or depression affects sleep schedule. It can be that it increases, it can be that it decreases, it can be both. And since we have not mentioned both, we mentioned which one it is we are looking for, we have to consider both sides of the tails, that is a two-tail test. In this case, alpha level, so for example, let's say alpha level out here is 0.05. Then this part, this is 0.05. This part, this is 0.05 because it's a one-tail test. But if for a two-tail test, alpha level is 0.05, then this little area on one side will be 0.025 and on the other side also 0.025. So both of them together makes up the full significance level for a two-tail test. 0.05 means 5% of the scores fall here, 5% of the scores fall here, 2.5% of the scores here, 2.5% of the scores here. Total is 5%. See, 2.5, 2.5 and 5. P 0.05, 0.05 together P 0.95 or out here. Wait, this is 0.05 and okay, this one I think there's a mismatch in the data. So don't focus on this one, focus on this and this two. Now, based on the tails of the test, is it a right tail test or a left tail test? This one is very important. So when the H alternative, HA means H alternative or alternative hypothesis. This is where, so this kind of a statement says that we are looking for the increased value. Like motivation increases performance. Whenever the direction of change is increasing or improving, basically getting higher, then we say that it is the right tail test because we are looking for the higher or positive side, which is the right side. Or we know how the number line, how it works, 0, +1, +2. Out here we have -1, -2, right? Oh. We have -1, -2 like this. So positive is on the right side, negative is on the left side. So when you have to look for a value that is where the alternative mu is the mean, we will get into that with other statistics, not right now. So when okay, let's ignore this side. Just say whenever there is an increase in value that we are looking for, motivation increases performance, caffeine increases attention, um, stress increases chances of depression, then we are looking at the right tail test. When we are looking at the reduction side, that is stress reduces performance or stress reduces immunity or anxiety reduces working memory capacity. Then we are looking for the other side, the negative side, that is a left tail test. And when nothing is mentioned, it's a non-directional hypothesis, we are looking at two-tail test. So please remember that for directional hypothesis, not only is it one-tail test, which direction? Positive direction, right tail test, negative direction, left tail test. Now, let's get into the significance level. So how do we decide the significance level? How exactly are we getting these values? For the data to have any significance, that is for you to state that, yeah, okay, today it rained, right? Significance means that it rained. There is a relationship has been found, which is why we keep on saying that a high level of significance or significant differences has been found, right? So significance means the relationship. Now, for us to say that there is a relationship between the clouds and the rain, that it did actually rain, it must be more than on normal days. If it is not more than normal days, how can we ever state that on this day it rained? It is just normal. It is how every day is. So it has to be a bit different from the normal situation. In technical terms, the measure of the sample who received the IV, in this case clouds, should be different than the population who did not receive the IV, that is baseline. That is the rain amount on this particular day, that is on the day that you are looking for, should be different than on other normal days, which serves as the baseline or comparison. P-value is the chance that the test statistic fits the population. The population is taken as the baseline. That's if the chance that this kind of rain is normal for every day, which means there is no effect. So for the rain to actually have an effect, the value, the critical value that we get, it has to be more than the normal situation, more than normal probability. So in this value, in this example, p-value is chance that the rain measured is the same as normal days. Alpha level, minimum amount of rain for us to conclude that the raining is more or at least different than normal days. Hence, if p-value is higher than alpha level, we fail to reject a null hypothesis. We fail to say that there is a relationship. Because whatever happens normally is already more than whatever minimum amount you have stated. So what relationship are you talking about? So if p-value is less than or equal to alpha level, that is the normal situation, is less than the minimum amount, then we say that we can reject the null hypothesis. That is how we reject the null hypothesis, by first discovering the p-value or what the normal thing is, what the population is like. Because my sample to whom I have given the independent variable is supposed to have different scores than the population baseline. The stricter the alpha level, the higher is the minimum amount of rain required, and stricter alpha level, more different, the result has to be from normal for null hypothesis to be rejected. That is, stricter the alpha level, higher chance of confidence, hence stricter the alpha level, higher is the confidence. Example. For alpha level 0.05, implication is that null hypothesis will be rejected. only if the chances of the test statistic or score not fitting the population, this is the p-value is less than 5%. This is the rejection region. This is the critical value. Critical value is computed based on the significance level. In other words, there is an about 95% chance of confidence that the test statistic indeed fits the population, which means 95% chance that it is normal. If it still doesn't, it is normal. If it's still not normal, which means there must be an effect. Now, I hope this part is clear to everybody how exactly we discuss the hypothesis testing. And because hypothesis testing itself is not an issue. It is a very easy thing to do, but we often get lost in the technical terms. So we just took a very normal everyday example. First wrote it in the everyday ways and then translated it into the technical terms so that you get to make a very clear relationship. Now let's look at the errors in hypothesis testing. The kinds of errors that we make is again an area that students frequently ask about. Let's get back to the two possible hypotheses. It will not rain. I do not need an umbrella. There is a null hypothesis, no relationship. Yes, it will rain. I will take the umbrella. This is the alternative hypothesis. The two possible outcomes are it did not rain versus it rained. So which leads to four possible combinations. Two hypotheses, two outcomes, four possible combinations. These are the combinations. Hypothesis, it will rain. It did not rain. Null hypothesis is accepted. It will not rain. It did rain. Null hypothesis is rejected. It will rain. It did not. So now these two we are talking about these two are the null hypothesis. These two are the alternative hypothesis. It will rain. It did not rain. Alternative hypothesis is rejected. It will rain. It rained. Alternative hypothesis is accepted. An important thing to notice out here, you see, whenever we compare the outcomes, that is, it did not rain. I'll take another ink so that it gets easier to see. So it did not rain. It did not rain. So when you see these two outcomes, you see null hypothesis accepted and alternative hypothesis rejected is the same thing. Similarly, it rained. Null hypothesis rejected and alternative hypothesis accepted is the same thing. So both of them are totally dependent on each other. So rejecting one automatically means that you accept the other. Accepting ones automatically means you reject the others. So whenever we are talking about errors or hypothesis testing, focusing on just one of them, that is the null hypothesis, is enough for us to reach the conclusions that we require to. This is the same table as the last one, just with more technical terms. That is, it is framed in a much more technical way. And these are the languages that is used in the examination. The examination will rarely use this kind of language. They will use more this technical language. This is whatever is easy to us. This is the correct format. Since rejecting null hypothesis is the same as accepting null hypothesis and vice versa, let's focus on null hypothesis now. Null hypothesis, outcome is no relationship, null hypothesis accepted. What will be the error? Null hypothesis rejected when it is actually true, because the outcome has stated that there is no relationship. Then if we reject the hypothesis, then because rejecting null hypothesis means there is a relationship, then that is an error. Which kind? The type 1 error, rejecting a true null hypothesis. If the outcome is that there is a relationship, then null hypothesis should be rejected. That is the correct conclusion. Error would be a null hypothesis accepted when it is actually false. This is the type 2 error. Accept a false null hypothesis. And this table, if you are able to remember this table, the hypothesis, the outcome, the correct conclusion, the error, and the type of error, you're almost like all of your hypothesis testing error problems will be solved. So Type 1 error is called a false positive, rejecting a true null hypothesis. Test shows there is a relationship when there is not. Type 2 error is a false negative, accepting a false null hypothesis. The test shows that there is no relationship when actually there is one. The correct outcomes are also called a true positive, that is showing a relationship when there actually is one. So I'll write it out here also. So this is a true positive showing a relationship when actually there is one. A true negative saying that there is no relationship when actually there is none. Strict alpha level makes it difficult to reject the null hypothesis, right? We have discussed that the stricter you make the alpha level, the more less is the chance that the data will fall beyond the alpha level and more difficult to reject the null hypothesis. So the more difficult it is to reject the null hypothesis, more difficult it is to make type 1 error, because type 1 error, as you see, is about rejecting the null hypothesis. Type 1 is about rejecting the null hypothesis. So we make rejecting the null hypothesis more difficult. We reduce the chance of type 1 error. So increasing or making the alpha level very strict, it makes it difficult to make type 1 error. If the alpha level is lenient, it makes it easy to make type 1 error. Hence, alpha level is equal to chance of type 1 error. If the alpha level is lenient, that is somewhere around here, then see how easy it is that a data that falls here will also be able to reject the null hypothesis, even though there may not be an actual relationship. So lenient alpha level makes it easy to make a type 1 error. For example, certain kind of alpha levels, 0.05, that there is a 5% chance of that there is a type 1 error. And by the way, these parts, they will ask you the alpha level and then ask you what it means in terms of making a type 1 error. These things do come in the question, so please be mindful of these. 5% chance, so whatever the alpha level, 5% chance of type 1 error, alpha level 0.01 or 1% chance there is a type 1 error. More strict alpha level, and by the way, type 1 and type 2 error are very close to intimately related, because understand one thing, that we already discussed that rejecting one hypothesis is automatically accepting the other hypothesis, right? So type 1 error is about rejecting, type 2 error is about accepting. So if we make rejection very difficult, we are also making acceptance very easy. Similarly, if we make rejection easy, we are also making acceptance difficult. So which is why increasing of type 1 error automatically means more chance of type 2 error, and more chance of type 1 error means less chance of type 2 error, which basically means that for a strict alpha level, chance of type 2 error can increase. So which one do you choose? Because this way we were going on focusing on how a strong strict alpha level is good for us, but we are also seeing that having a very strict alpha level can also lead to errors. So how do we choose what kind of alpha level to make? Alpha level is chosen based on which error has more severe consequences. So let's look at some examples to make it clearer. Choosing the significance level. Let's go back to our rain example. Equating with the rain example, you have two possible choices of action. Take umbrella means that believe that clouds do predict rain, that is, there is a relationship. So taking umbrella is the same as rejecting the null hypothesis. Don't take the umbrella, believe that clouds do not predict rain, believe that there is no relationship, that is, accept the null hypothesis. So taking umbrella, rejecting null hypothesis, don't take umbrella, accepting null hypothesis. Let's look at the 4 possible combinations based on the outcomes. It did not rain and you took the umbrella. It did not rain, you took the umbrella. You have to carry it unnecessarily. Did not rain means that, so you took the umbrella means reject the null hypothesis, but you falsely rejected it. Actually, there was no relationship. So it is the type 1 error, carrying it unnecessarily. You took the umbrella and it rained. Perfect. You did not take the umbrella, it did not rain. Again, perfect. You did not take the umbrella and it rained. What happened to you? You got wet. What kind of error it is? It is a type 2 error. Don't take umbrella means accept null hypothesis, accept no relationship. You go out, there was a relationship and you actually got wet. So carry it unnecessarily, type 1 error, get wet, type 2 error. We make a decision based on which error is considered worse. In this example, inconvenience of carrying it unnecessarily versus getting wet. Whichever one is more adverse to us, whichever one we consider to be worse, we will try to make the opposite decision. That is, if we think getting wet is worse, then we will not accept null hypothesis. We will reject the null hypothesis and take the umbrella. I equate these two, or you know what, I'll just use a separate color. That makes it easy. That is, if getting wet is worse for you, you will take the umbrella or reject the null hypothesis. If carrying the umbrella unnecessarily is worse for you, then you will not take the umbrella and accept the null hypothesis, which also means that if type 1 error is worse, we make if we believe that type 1 error has more consequences, we make the alpha level stricter. And if type 2 error has more consequences, we make the alpha level lenient. Now some more significant examples of it. Believing there is a relationship between a religion and time rates when there is none has a more severe consequence. Actually, the religion and crime is not related. But when you think that there is a relationship, there can be civil social problems, civil consequences, legislations, fights, communal problems, and hence assuming that there is a relationship when there is none, that is a type 1 error, is considered more significant here, and hence alpha level should be strict. Look at the other side. Believing that there is no relationship between prenatal drinking and birth defects when there is one has more severe consequence. So let's assume that birth defect and prenatal drinking is not at all related. Prenatal drinking by the mother when she is pregnant. Imagine that they are not related. Fine. But we assume that they are related. Right? So in that case, what happens is just some pregnant mothers does not get to drink because you are advising against it. But imagine that if actually there is a relationship and you don't accept it and you just accept that there is no relationship, then what happens? Then babies get born with birth defects. So the point is out here, assuming that there is no relationship, when there actually is one, has a higher consequence, more severe consequence. Hence, alpha level should be lenient to avoid type 2 error. Because out here, in the first example, we don't want to find a relationship until and unless there absolutely is a relationship. In the second example, we want to find the relationship if there is even a small one, because we are trying to avoid the birth defects. This is how alpha level is chosen, based on which error has a more severe consequence, and based on that, alpha level should be made more strict or more lenient. Based on that, alpha is the chance of type 1 error, beta is the chance of type 2 error. That is inversely proportional to alpha level. Please remember this again and again. I have been telling students for so long. Beta is inversely proportional to alpha level. That does not mean that beta means 1 minus alpha. No, alpha is not 1 minus beta. Those are separate. We'll get to it very soon. Higher the alpha level, lower is the beta. Lower the alpha level, higher is the beta level. This has to be the truth. Because basically, higher the chance of type 1 error, lower the chance of type 2 error, higher the chance of type 2 error, lower the chance of type 1 error. But that does not mean a direct equation. Look at this. Alpha, probability of incorrectly rejecting a true null hypothesis, right? So alpha level is the possibility of rejection. So when you make a type 1 error, what are you doing? You are thinking that the data stays around here, while actually the data stays around here. You have incorrectly rejected the null hypothesis, which you should not have done. That is a type 1 error, right? So whenever if this is the alpha level, or this area represents the alpha, or chances of making the type 1 error or make an incorrect conclusion, this area, this entire area, that is 1 minus alpha, is the chance of making the correct conclusion, which it actually is. This is the correct conclusion. So 1 minus alpha means the chance of correctly accepting a null hypothesis. Fail to reject is the same as accept. So this 1 minus alpha is our probability of correctly accepting a null hypothesis. So 1 minus alpha is probability of correctly accepting a true null hypothesis. Now look at beta. When we are looking at beta, so I've already used this for alpha, so I'll use another color for beta. So let's use blue for beta. So in beta, what is the type 2 error? Which in type 2 error is acceptance of a false null hypothesis, which means we are thinking that the data is around here. We have accepted the null hypothesis, while in reality, the data is around here, right? So in this case, what is happening? So this part where we have mistakenly assumed that this is the correct one, while actually there is a relationship. That is what a type 2 error is. So this part, this entire chance of accepting the significance level or accepting the null hypothesis, that is beta, and our chance of making a correctly rejecting or correctly finding a relationship is 1 minus beta. So this side is 1 minus beta. That is correctly finding that there is an actual relationship. A correct rejection of null hypothesis. That is 1 minus beta is the probability of correctly rejecting a false null hypothesis. This part, this entire part, it comes in the question. So please be clear with it. This is the alpha, and hence this is 1 minus alpha. If this happens to be the type 1 error, then this is the correct acceptance. This is the beta level, and this is the 1 minus beta representation. This happens to be the mistake or type 2 error, which means the correct conclusion or 1 minus beta is correctly rejecting our false null hypothesis. False null hypothesis means that there is actually a relationship. Now, even though in this particular chart, 1 minus b and beta and alpha and 1 minus beta looks the same, it is not. Because right now, we are only talking about the specific concepts. We are not discussing the complex statistical calculations. So this is not the same as being equal. This is simply proportional to each other. Now, beta is equal to 1 minus p, where p is the power of the test. Power of a test is the ability of the test to correctly detect a real effect or a difference when it is truly there, which basically means power of a test is probability of correctly rejecting a false null hypothesis, which you can see over here. Probability of correctly rejecting a false null hypothesis, this is 1 minus beta. So power, probability of correctly rejecting false null hypothesis, which will come to 1 minus beta, and this is the equation. Hence, power of a test is directly proportional to alpha level. Again, proportional, not the same. Power, please remember, power is associated equation-wise with the beta level, not the alpha level. But since beta is directly proportional to alpha level, so the beta is inversely proportional to alpha level. So power is directly proportional to alpha level. Beta is inversely, power is directly. As 1 minus p is probability of incorrectly accepting a false null hypothesis, because power is probability of correctly rejecting, 1 minus P probability of incorrectly accepting. And one thing to notice is that when correctly becomes incorrectly, rejecting becomes accepting. It is always like that. I'll show it here also. See, incorrect became correct, reject became accept. Incorrect became correct, accept became reject. Please keep this relationship. Whenever you are changing one thing from incorrect to correct or correct to incorrect, you have to change from reject to accept or accept to reject. This has to be remembered. Now, so hence, power of a test, probability of correctly rejecting a false null hypothesis, 1 minus P probability of incorrectly accepting, you change from correct to incorrect, reject to accept, from power or P to 1 minus P. Hence, 1 minus P is chance of type 2 error. Probability of incorrectly accepting a false null hypothesis. That is literally type 2 error. So, it is chance of type 2 error is equal to beta. So, probability of correctly rejecting a false null hypothesis is equal to 1 minus beta. Beta is equal to 1 minus P and power is equal to 1 minus beta. Please remember these relationships. They come in the questions. Power is directly proportional to the alpha level. Beta is inversely proportional to the null hypothesis. And this is again the same thing, but written in alpha and 1 minus beta. So 1 minus beta, 1 minus alpha format written in the table format. So it becomes easier to understand. So I hope this simplified the concept by relating it to real life examples and doing very basic statistical calculations from one side to the other and of proportion and just taking the normal distribution, showing what happens when you move from one side to the other. So I hope this clears out hypothesis testing. Our batch will be starting on 9th August with full syllabus coverage, weekly mock test, concept clarification, and short papers. This goes without saying. Live and recorded classes, all recorded classes will be available till 1 year of the start of the program. There will be unit-wise mock tests for all the units for targeted preparation to the point study material so that it gets simpler and easier to study. Exam strategy for which I will be personally helping you out with your study planning and scheduling. The course fees is 2499. First, for the first 10 students, it is 1999. Enrollments have already begun, so please enroll as fast to get the offers. This is the number at which you can text or this mail. Please remember, it is Psych Academy, not Psycho Academy at official@gmail.com. These are the other courses offered, which you can pause and check. Thank you, everybody. Next demo class will be on logical reasoning syllogisms. Thank you, everybody.